Hello guys, welcome to Math City with Miss G. In this video, we are going to talk about parallelogram. What are parallelograms? Parallelograms has multiple properties, and these properties are important to remember when we are dealing with problems that involves parallelogram. The illustration on the right-hand side is an example of a parallelogram. Now, let's use this figure to analyze the properties of a parallelogram. We're going to start with the first one, which is opposite sides are parallel. So that means if I'm looking at segment AB, it is parallel to segment DC, as well as segment AD is parallel to BC. The second information or bullet is opposite angles are congruent. So that means I could use this side or this side segment AB, which is congruent to its opposite side, which is segment DC. Segment AD, which is opposite to BC, are also congruent at the same time. Let's move on to the next one, and that is opposite angles are congruent. So I'm looking at angle A that is opposite to angle C. We also have another angle that are opposite to each other. We have angle D, which is opposite to angle B. And opposite angles are congruent, meaning equal in measure. The fourth bullet is consecutive angles are supplementary due to parallel lines. Example, we have here measure of angle A plus measure of angle B. A and B are considered supplementary. They're right next to each other. These two angles are right next to each other. So when they're added together, it is equal to 180. Another example that we have here is measure of angle A plus measure of angle D. A, which is on this side of the figure, plus D is equal to 180. So these two angles, A and D, are examples of consecutive angles. There are more examples to this. Let's move on to the next one. Diagonals bisect each other. I am going to draw a diagonal in this figure. So I'm looking at DB. That's a diagonal. And then the second diagonal, there will only be two diagonals in a parallelogram. So when we say diagonals bisect each other, it creates two equal segments. And what segments are we talking about? I am talking about this side be congruent to this side. And the last one is that this part of the diagonal is congruent to this part of the diagonal. Let's summarize that information. I'm gonna name the middle letter with F. So I am going to write the example here. Segment AF is congruent to segment FC. It makes a whole diagonal AC. The other pair of congruent pairs using diagonals bisect each other is segment DF or FD is congruent to segment FB or BF. Only two pairs. There will only be two pairs of congruent segments created out of the diagonals. And the last information is about alternate interior angles are present. Because parallelogram, from the word parallel, okay, we are talking about parallel lines cut by a transversal. Alternate interior angles are present. I am going to show you an example in a few minutes what this looks like. Let us use this information to try and answer number 1. So I'm looking at angle U, and angle U is opposite to angle S. U and S are opposite angles, and opposite angles are congruent, so meaning equal in measure. So that's how I know that angle S is also going to be 66 degrees. Let's move on to the next one. We have angle C, relationship of angle C and angle D. They are consecutive angles. So let me write consecutive angles. And consecutive angles, when added together, is equal to 180. They are supplementary. So that means I can add this two or do opposite. I'll do 180 because I know that the sum is 180 minus 136. That will leave me with 44. So therefore, angle D is 44 degrees. Let us try another problem. Number 3. Okay, so if you have a highlighter, let's go ahead and highlight this portion of the figure. TU is parallel to SR. Now I'm also gonna highlight this particular line, which is a transversal line, considered a transversal. So I'm gonna write the word transversal. So remember what transversal line was when we talk about parallel lines? It is a line that divides or cuts a pair of parallel lines. So if you look at the figure closely, we have here a triangle. We want to find this angle, the question mark, but we can't find that angle unless we find this angle. Okay, so how do we find this specific angle? Okay, so we can do, remember the sum of the interior angles of a triangle is 180. So I could do 180 minus 62 minus 70. And whatever is left is a measure of the missing angle. And that should give us 48 degrees. Now, if that is 48 degrees, then this angle, the green angle, the missing angle, the question mark, will also be 48 degrees. Why? Because these two green angles are considered alternate interior angles. And alternate interior angles are always equal or always congruent. So I'm going to highlight this information so when I look at this information later, I will remember that they are considered alternate interior angles. Number 4, we're looking at opposite sides. We have this side, CF, is parallel to segment DE, and DE is equal to 21.8. Therefore, this side will also be 21.8. Why? Opposite sides of a parallelogram are equal or are congruent. Okay, so I'm writing the information why we know, how do we know that these two sides are congruent. Let's try another problem. Number 5. Okay, so we're given with SU. So SU in the problem is a whole diagonal. This is SU. We are asked to find HU, and HU is half of a diagonal. So if you're thinking of dividing SU by 2, you are right. So we are going to divide 42.4 by 2, and that gives us 21.2. So this angle, this part of the figure is 21.2. So HU is also 21.2, while this other side will also be 21.2. So all right, let us move on to another problem. So let's take this to the next level. Okay, so this time we are including algebraic expressions. So we have here, we are asked to find the missing angle. I mean, not missing angle, but missing variable. So the missing variable here is x, and we can't find x unless we are able to find this angle here. How? Because this line is parallel to this line, and we have a transversal line. So that means this purple angle will be the same as this angle right here. So we have to find this purple angle first, okay? Because this is an example of alternate interior angles. And alternate interior angles are always equal or are always congruent. So let's go ahead and find this angle. So we can do 180 minus 103 minus 37. And whatever is left is the measure of that angle, and that is going to be 40 degrees. So this angle is 40, therefore this angle is equal to 40 degrees. So this is how we are going to solve this problem. 6x minus 8 equals 40. Isolating x, we'll have 6x equals 48. And if you got x equals 8, you are right. Let's try another problem. Okay, so we have angle V and W. These two angles are considered consecutive angles. And consecutive angles are supplementary, meaning when added together, it's equal to 180 degrees. So to solve for the value of x, we can set up our equation by adding angle V plus angle W, which is equal to 180, because this angle is supplementary to this angle. They are considered consecutive angles. Okay, let's go ahead and substitute. So we've got 65 plus 10x plus 5 equals 180. Combine like terms, we have 10x plus 70. Adding these two together, we're going to subtract 70 on both sides, which would give us 10x equals 110. Divide both sides by 10. X is equal to 11. Let's try another problem. Okay, for number 8, we are given two angles that are opposite to each other. So angle E is opposite to angle C. So opposite angles. And remember, opposite angles of a parallelogram are equal. And since I know they're equal, then to solve for x, we're gonna set up our equation by putting an x in between them, because they are equal or they are congruent. Let's go ahead and isolate x. So if you got x value which is equal to 2, then we've got the same answer. X is equal to 2. Let's move on to number 9. Okay, so we're going to locate the given. So we have ln. Net ln is the whole diagonal. The other given is, that's ln. And then the other given is qn. And qn is half of the diagonal, the same diagonal. So therefore, we're simply going to divide 40 by 2. Because when we divide 40, the whole diagonal, we will get the measurement of each of these, which is going to be equal to 20. So to find qn, we are going to set up 3x plus 2, which would be equal to 20. Isolating x, we'll have 3x equals 18. If you got x which is equal to 6, we've got the same answer. Let's try number 10. So, number 10 is down below. Okay, so number 10, we are given with this side parallel to this side. They're not only parallel to each other, they are congruent because opposite sides of a parallelogram, if you look at the properties of a parallelogram, they are congruent, meaning they are equal. So knowing that they're opposite sides and they're equal, so then therefore we can solve this by setting it up, putting an equal sign in between the two given sides, given measures. So I'm going to subtract 2 on both sides. This will leave me with x equals 2x minus 11. And I'm going to subtract negative 2x on both sides. So this gives me negative 11 is equal to negative 11. We want to get the x by itself positive. So x is equal to positive 11. Let's go ahead and try this in a different set of problem, number 11. So for number 11, we are given with angles that are opposite angles. And remember, opposite angles in a parallelogram are congruent. So opposite angles are always congruent or equal. Therefore, to set up our equation, we'll have 9x minus 6 equals 7x plus 12. Let's go ahead and isolate x. I am going to do inverse of negative 6. That would be positive, leaving me with 2x equals 18. Therefore, x is equal to 9. Now, go back to the question. On the question, it says find the measure of angle W, and that's this angle right here. So that means we're going to substitute. Okay, we do not stop at x. So 7 times the answer that we got, which is 9, and then plus 12. So doing the math, we have measure of angle W, which is equal to 75 degrees. So our final answer is going to be 75 degrees. Let's try one last problem. Okay, so when you see something like this, I would highly recommend you use your highlighter. We've got DQ, and DQ is this portion of the figure. The next one is QF. QF is the other half of the same diagonal. Remember, diagonals of parallelogram bisect each other. So that means we are given here with half of a parallelogram. Not half of a parallelogram, but half of its diagonal. So that means, remember, half of a diagonal of a parallelogram, they are going to be equal to each other. So therefore, knowing that they are half of the same diagonal, therefore we can set up our equation into 2x plus 3 equals x plus 8. Let's go ahead and isolate x. So we'll have 2x plus 3 equals 8. Inverse of positive 3 is negative 3. And 2x is equal to... hold on one second. I apologize for this mistake right here. When I subtract 2x minus x, this should just give me with an x. There you go. I stand corrected. Okay, now 8 minus 3 is equal to 5. And going back to the question, we are asked to find dq. So let's go ahead and find the measure of dq. So dq is equal to 2x plus 3. So 2 times the answer that we got, which is 5, and then plus 3, our final answer dq is equal to 13. I hope you find value in this video. Thank you for watching. I'll see you in my next one. Bye.